would like to explain path-related security application in 5G. Since 5G uses network function virtualization to serve three big plans of applications. One is ultra reliable and low latency communication, and the second is enhanced mobile broadband communication, and the third one is massive machine type communication. So there will have billions of devices are connected in the network. The attack services by hacker will be increased drastically. To secure the network and the individual user become imperative in 5G applications. So to talk about security, let me begin from the root of trust. What is the root of trust? Root of trust is a source that can always be trusted within a cryptographic system. And what is the cryptographic system? Cryptographic security is depend on keys to encrypt and to decrypt data, and also perform functions such as digital signatures. So from these two statements, we know that the most important for a system to be secure is to have an always trusted key in the system. So what can be always a trusted key? Is the key generated by software algorithm be trusted? The answer is no, because it uses algorithm. Can the key inject into a system by an operational engineer to be trusted? The answer is no either, because it may be disclosed through the human operation. So what kind of key can be always trusted? The answer is a key generated or derived from natural randomness in a chip. By doing this, no algorithm and no human theft can cause the leak of the key. So our new path is generated in the chip by using the randomness of the oxide quality during IC processes. Therefore, it serves as the always trusted key, because it is random generated and it is already on the chip without operator to inject it into the chip. So after we know that we know what is the root of trust and how to create very secure key for the root of trust. Next, I would like to explain how 5G uses such key. In the 5G application, all users request the service from 5G. The first step is the authentication process to let only authorized party to access 5G network. So the simplest way is to give user an unique ID from the telecom operator, such that user can use this ID to request service. For example, when we register to use a telecom service, we will be issued a SIM card, and user ID is given in this SIM card. It shows three cases of how user ID, a unique ID, UID, can be stored in the SIM card of the cell phone. One is the method used now, and the case 2 and 3 are proposed a new method which use PUF to significantly increase the security of the applications. Case 1 is the one I have just talked about, to have operator to write unique ID as root key and store in the issues. In such method, the attack service are obviously exposed. One is on the operator, and the other is on its storage in eFuse. And the eFuse is visible from its storage of data. So hacker can get the unique ID directly from eFuse using reverse engineering. For the case 2, we can improve the security of case 1 by using POP in the SIM card to scramble the unique ID injected by operator to become a new ID, such that the attack surface on the operator is eliminated. In addition, the new ID can be stored in OTP. Here we call it POP key storage, which is non-traceable, and the data will not be disclosed even after reverse engineering. And the even secure case will be in case 3. In case 3, no operator needs to inject the key. The SIM card can generate the unique ID from its embedded POP. So the POP is stored, the key, the unique ID is stored in the POP. So there's no additional storage needed for storing the unique ID. So once you have separately storage for the unique ID, then afterward you can use that for all kinds of key generations. Will be the authentication process in 5G. And since it's a little bit complicated and will take much more time to explain, so I will leave this to you. You can go through this step by step and learn how the authentication is proceed after you have a very secure key or secure unique ID generated in your SIM card. And I can give you some example. When you use your credit card to purchase online, to do the online purchasing, and the store will send you, or the company you want to buy goods from will send you a number, ask you to verify. Actually, when they send those numbers to you, they are encrypted, and when your cell phone receives those encrypted numbers, you can use the same key you have and the service company has to decrypt the number they sent you. So after you see those numbers, then you type in, and then the key will encrypt those numbers and send back to the service company. So they will, after they use the same key to decrypt, and they get the number you type in, and if the number is equivalent to the number they send you, then you are authenticated. Then all the purchase process will be complete. So I think that is what I want to explain, the application of POP-related security in the 5G.